Okay, so it's been a while since we've last talked, and it's been I think 7 months since we've done an update, and we've been doing a lot of work behind the scenes. Matt, you especially have been doing a lot of work
That's right.
developing the models. Yep. And so we just wanted to give everyone an update on the status of the project, what we've been doing, what we're thinking about the future, next steps, and ways you can help. So, first of all, the biggest question that everyone obviously wants to know: what have we been doing? Are we? Is the project still alive? Are we actually working on anything? The answer is yes. We're still. The project is still alive. We're still working behind the scenes, even though there hasn't been a lot of like public announcements. So, Matt, could you explain real fast what you've been working on over the past couple months with this whole CS:GO proof of concept thing?
Yeah, I took a popular off-the-shelf, state-of-the-art deep learning model designed for video classification, and I repurposed it for CS:GO cheater detection. And so uh, I scraped all of the YouTube clips that were submitted to our servers and trained the model on those clips to detect if a clip was a cheater or a not cheater playing CS:GO.
Okay, so that's a big simplification. How long did this take you? Like, what sort of things did you run into? Because, obviously it's taken a little bit for us to get here.
Yes, yes, I know. It all sounded fancy, but it did take a lot longer than I originally estimated. I thought it was gonna take like for me 10 hours. I thought I could whip it together, but it was more like 25, 30 hours. Yeah, many nights just going through the whole process of setting up the server from scratch and collecting all the data in a nice,
Mm-hmm.
robust way that we can easily train on these video clips. And
Mm-hmm.
uh, yeah, it was very hard to get these modern video models to work because I worked with video games, uh, 5 years ago, and it was really easy to train a model back then. And
Mm-hmm.
now they're a lot more sophisticated. Not a huge hurdle, but a lot,
Mm-hmm.
a lot more than I was expecting. I also didn't realize how hard it was going to be to clip out just kill shots. I thought that would be fairly trivial. Turns out a lot more difficult than I was expecting. So a lot of the effort went into just can we find where the kill is in the game. But with like 100 labels, we were able to get a pretty robust
Mm-hmm.
model for that. But yeah, now we have a nice. I think will work with any type of video based data set. So any other video games. Yeah, it's a pretty great model right now.
Mm-hmm. Okay, so what sort of results did we see with just and for context, we captured just CS:GO clips for this first proof of concept. It was a relatively small data set, but we did try and use as many clips as we could find from the community for especially for the pre-training process. And then we did do a bit of fine tuning to actually do the classification of cheating or not cheating. What sort of results were we seeing with this sort of small data set that we had, and how confident are we that this will scale well, or this will we could reproduce the results given like a larger data set?
Yeah, so I think our pre-training data set, which was just videos of people playing CS:GO, that was very big. Plenty of clips submitted, and we had like 700 different video clips. I think that was like 30 hours, and so that was plenty. Um, but yeah, we only had 100 or 200, maybe 200 labels of kill shots, and so it was pretty tricky to get that model to be reliable because that was finding where the kills were downstream to actually detect the cheaters. And so that was okay, but it did require a little bit more manual pruning from me just to make sure that we were picking up on the kills. So I think for that we'll need a little more than 100 labels.
Yeah.
Then for our cheater data set, it was also pretty small. I think maybe a total of uh, 200 instances of cheater versus non-cheater kill clips. And I'll just say, like the fact that we're doing better than random guess is a very clear indicator that our model is actually learning the problem appropriately. So if we got significantly more data, I'm very confident that the model would perform extremely well.
Okay, so I'm going to throw up on the screen right now a graph of some of the results of this initial prototype. And Matt, could you kind of explain what this graph means?
Yeah, so this is a typical graph that you would see for small data sets when you only have one thing you're trying to detect, true or false. And so here we're plotting the difference between false positives and false negatives. And so the real important part here to look at is if we tell the model, make sure you have no false positives, that means don't label anyone uh, as a cheater if you're not extremely confident, then we have a pretty high detection rate. Granted, this was on a small data set, but getting such a high accuracy with no false positives is very promising. And so we can see if as you modulate how confident you want the model to be, you can change how many people you would classify as a cheater. And so as you skew that over to the just be very confident part of the graph, then that's a clear indication to me that if we get more data, we'll be able to tune the model to be only confident when it knows it's a cheater.
Gotcha. Yeah. Well, that's really promising. I think, yeah, like you're saying, with a lot more data, we'll be able to get pretty accurate. We'll be able to classify a good amount of cheaters as cheaters without falsely labeling anyone, because we really want to make sure we don't want to label anyone a cheater that's not cheating, because
Exactly.
we
Yes.
know how bad accusations can be, and that's definitely not something that we're trying to start here with this project. So okay, so you mentioned before how one thing that we learned was that, segmenting the clips into just the points of interest, right? Like when a kill occurs is a harder challenge than we thought. That's definitely something we learned. Are there any other things we learned that are informing our next steps, and what are those next steps going to be in terms of the Waldo Vision project? Training on gameplay video.
Yeah. I think the biggest challenge that we're going to face is just having an accurate kill segmenter. And so for some games like CS:GO, you can look at the kill feed and do some hand manipulation to find when kills happen. But it's not entirely easy for every game because there's always edge cases that really screw up the data. And if you have very biased data from some bad parser, then yeah, you're it's just gonna ruin your model. And so I think making sure that for every game that we go forward with, that we have a very well vetted uh, kill segmenter, whether that's AI based or more manual based. And
Mm-hmm.
so I think having if we can just manually tune it for each game rather than having to train the whole neural network, that would be ideal. It'd be much easier to
Mm-hmm.
ensure that we have good data sets for training the cheater detector.
Right. Is there a possibility of doing something like transfer learning where, okay, now that we have this model that works for CS:GO, would it make it any faster to train on another game down the line?
um, Yes, yes, you would. So that's an entire field of machine learning is not just transfer learning, but it's called domain adaptation or domain generalization. That's actually stuff I work on at my day job. And so if we, yeah, if so we have a big, nice data set for different games and a new game comes out, in theory, we could retrain our model with domain generalization techniques. And then it might just work out of the box. And because right, cheater cheats between different FPSs should the underlying process, the neural network should be able to pick that up, even if it's never seen the game before.
Mhm.
And so if we get large amounts of data, then yeah, transferring between games. In fact, it probably would be useful just to have one single unified model for every game.
Mm.
But if we get the data, we can run those experiments.
We'll get there when we get there.
Yeah, yeah.
Yeah. Okay, so we trained this initial model on CS:GO data, but now CS:GO is gone and it's Counter-Strike 2 now. So our next steps for the project are going to be to train this model on Counter-Strike 2, prove to ourselves that we can repeat the process using the framework that Matt has built, and train with a larger data set from CS2. So I've been working on setting up a Counter Strike 2 server to do testing on. We're going to do a similar process where we go in and record our own cheating data in order to train the model, but we're just trying to increase the scope a lot now that we don't have to build all the framework from scratch. So really a lot of the emphasis is going to be on collecting lots of data and training the model with all that data. So we're going to need your help with gameplay submissions just like before on the Waldo Vision website. So if you go play CS2 games and you record it, please go ahead and upload those to the Waldo Vision site. That'll help us train the model to understand what CS2 looks like. Then we also have a team that we're putting together in the Discord. The user Bubbles are awesome. He's been helping put together a team that's going to be kind of dedicated to going onto the server and capturing gameplay that they can label as cheating and not cheating, which will be used for fine tuning the model down the line. Matt, quick question on just a scale of magnitude, like 2 times, 3 times, 5 times, how much more data do you think we are trying to collect for this next round with CS2?
Yeah, I'm thinking at least 10 times. That's
10x. All right.
10x.
Sounds good. So you heard him. We're going to need your help to collect all that data. We're going to need a lot of it. But we're pretty confident with these results that we're going to be looking even better after we do the second round of training. Okay, so we're obviously been working on this Waldo Vision project with the recording gameplay and training the deep learning computer vision model. But we've also been having some ideas about some tools we might be able to build for developers as well. So what we're wanting to do, and we've been working on a paper, and we want to build a prototype FPS game ourselves where we can go in and collect data that you would actually be getting on like a dedicated server that's hosting your FPS match and to be able to extract that data and train a deep learning model on that as well. This is um, really more of a developer focused sort of process because in order to actually in real time or in order to ban a cheater, right, the developer is going to have access to it. So we're really interested in not only having something that you as a user could go submit gameplay and see if it's cheating or not, but also something where a developer could pull data from a match that they hosted on a server and have an idea of whether there are any cheaters in that match as well. So, like I said, we're trying to build a FPS game, just something simple. It's not fancy, not something that's going to be professional, but just a little prototype game that we can host ourselves so we can start pulling that data to train a model. So we're also looking for help building that. So if you are experienced in any sort of game development, or if you want to get experience and you want to learn, that's something that we could definitely use your help with as well. Right now, one idea that we had is Unreal's replay system. Looks like it could be a good candidate for getting that data off of a dedicated server. But if you have ideas, we're really open to it and we want to hear from you. So we definitely need your help. Um, Matt, do you have any thoughts on this? This sort of approach, building something that could run on a dedicated server, what sort of strengths would this have over, what we're doing right now with the gameplay, or conversely, are there any, downsides or drawbacks to this approach, or any thoughts?
Yeah. So doing just a pure video style, it's a nice community tool, and you can validate if someone was a cheater or not based off of maybe they were playing on Twitch and you wanted to double check their video somehow. But it's not an extremely robust way for game devs, right? Like having to run their own game, train a model on the pixels. It doesn't really make sense when you have access to the internals. And so, what's very nice about modern machine learning models is that you can train a model to predict anything if you have the right data. And so, uh, if you have access to the internals state of the game, every game tick, then it's really much easier to just train the whole model on all that data and be able to predict something. And so if you want to detect if someone is smurfing or someone's cheating, uh, stuff like that, it's much easier if you have access to that raw uh, yeah, raw internal state.
Hmm.
And so uh, yeah, I don't see any downsides if you have to choose between using your own server or using some vision based deep learning model. Definitely go with your server. And so I'm very confident that we can make a if we had a proof of concept, we would be able to train a model with extremely high accuracy. And if we get something like this up and running, it would be nice to have this as like a validation platform for you know you build a cheat and see if you can detect your own cheat. And so that's something that we're really interested in. I'm hoping for the paper that is
Hmm.
showing that we can build these extremely robust models uh, by using server side that would be much harder to detect using uh, vision pixel based methods.
Right.
And so yeah, if there's anyone interested in game dev, please do reach out. I would love to help guide you towards building the server that would be useful for us. And yeah, we're hoping to submit to a machine learning open source software journal. And so if
Hmm.
you're also interested in authoring a publication, it would be this is a great opportunity.
Cool. Thanks, Matt. Um, so just to to summarize and reiterate to everyone, project is still alive. We know, there's always so much feedback and so many ideas. This will never work, or you really should do it this way or that way. And just want you to know we hear you. Also, we said we're gonna put out a white paper. We got super busy, and then we realized certain things like this prototype took a lot longer than we were anticipating for a bunch of different reasons. We had to deal with some legal stuff, so we know um, you know we didn't have that out when we wanted to. We're still working on all that. Thank you for sticking with us. As a reminder, we need your help capturing gameplay, so submit it to the Waldo Vision site. That'll just help, especially Counter Strike 2 right now, because that's what we're focusing on next. If you have any game dev experience, we want your help building that little prototype FPS. And then, lastly, if you want to help us actually collect and label CES2 data by playing on our own custom server, that's also going to be really important to have a large data set there. So those are the three biggest areas you can help right now. Um, Again, thank you for sticking with us, and we hope to have an update for you sooner than 7 months from down the road. So sorry it took so long. Um, any final thoughts, Matt, before we sign off?
Uh, nope. If you want to get some machine learning experience, this is your place. Game dev experience, same place. I'd
All right,
love to help.
all right. Thanks, Matt. Thank you all for tuning in, and we'll catch you next time.